All right, Math 92, Unit 1, Lesson 2. Let's warm up by multiplying and dividing fractions. When you take two negatives together, whether you're multiplying or dividing, you're going to get a positive. So, like -1 times a -2 is a positive 2, okay? A -1 divided by a -2. Whether you write it that way or you write it that way, you're going to get a positive 1/2, okay? Two negatives make a positive, okay? One negative makes a negative. So if that's always been a problem for you, make sure you're putting that kind of thing in the calculator to double check. Put it on a flashcard. Make sure you keep it handy. You have to get that down, okay? So when you're multiplying fractions, remember you're kind of going across the top. So 1 times 1 is 1. 4 times 4 is 16. It says multiply across the top, multiply across the bottom. Make sure you put it into an improper or proper fraction. This is a proper fraction. 16 over 3 would be an improper fraction. Improper, and this is proper. We don't want decimals or mixed numbers, okay? So that's not the kind of thing we're putting in our calculator. Make sure that it's 1 times 1 over 4 times 4, which is 1 over 16, okay? A negative times a positive is going to be a negative, if you want to throw that negative in there. 3 times 5 is 15. 4 times 9 is 36, and then you have to reduce. Divisibility rules come into play. 15 is divisible by 3 because 1 plus 5 is 6, and 6 is divisible by 3. So 36 is divisible by 3 because 3 plus 6 is 9. 9 is divisible by 3. So if you want to use the divisibility rules to do, that would be good. Don't lose that negative. All right. Now, I don't like to make numbers bigger and then make them smaller. I like to reduce on sight. So I take a 3 out of this 9 and get a 3. So then I just multiply across and get my 12 and multiply across and get my -5. That works too. Okay? So like on this one, take a 7 out of the 49 and you'll get 7. Take a 7 out of 14, you'll get 2. And it doesn't matter, it's not the same term. This is the same as -15 times -14 over 49 times 45. Feel free to just cross it out of, as long as it's the numerator from the denominator, it doesn't matter, it's not the same term. Take the 5 out of the 15 and get a 3. Take a 5 out of the 49, or 45. Hang on. Oh, why don't we take the 5 out. You know what? 15 goes into 45, but we'll get there in just a second. Hang on. Oops, that's a 1, and that's a 9. No, it's not. Okay, let me do this one over again. I'm making a big mess all over that. Sorry about that. All right. Take the 7 out. Take 5 out. You don't have to do it all in one step. And if you do that by reducing, you don't have to make it bigger and then smaller. Because this one, if you multiply -15 times -14, you're going to get a positive 210. And positive 49 times a positive 45 is going to be 2205. And then you have to reduce this. Okay? So it just takes a while, whichever way you want to do that. Talk to your teacher if they accept both ways. All right, when I'm multiplying a whole number times a fraction, whole numbers are really the numerators over 1. Okay? So then you can multiply across the top. Negative times a positive is a negative. 1 times 7 is 7. Done. Leave it that way. It does not reduce, okay? They have no factors in common. Put that over a 1. Now, I can redo this away. Here, let me just do it both ways. Negative 9 times negative 5. I choose to put that negative on top because I think it's just easier to think about it that way. Negative times negative is a positive. 9 times 5 is 45. 9 times 1 is 9. That makes a 5. Or you can sit there and cross both of these out. Cross both of the plus and minus out, and all you're left with is a 5 over a 1, which is a 5. Okay? 9 into 27 goes 3 times. So this one is negative 6. Negative 3 times 2 is a negative 6 over 25. Done. Okay? All right, what if we were dividing fractions? The expression I like to use is keep, change, flip. Keep the first problem the way it is. Change the division sign to a multiplication and use the reciprocal of the second fraction or flip it. Okay? Then multiply. Done. All right? No mixed numbers, no decimals. Leave them as improper fractions, please. Keep, change, flip, and then if you want to multiply across, you can, and then reduce, but I like to, that's going to be a 1 and a 1, take a 4 out, that's a 2, take a 4 out, that's a 3, so that's going to be 3 over 2, okay? Make sure you reduce your fraction all the way. It's required whether it says it or not. All right, this one is a division and then a multiplication. Remember, under PEMDAS, please excuse my dear Aunt Sally, make sure you do the division first because it's the first one you come to. So keep, change, oops, try that again. Keep, change, flip, and then if you want to, you can certainly add this other one on here like that. Now they're all multiplied together. I did not multiply them all together and want to get a really big number. I reduced. So let's get a different color here. So I took 3 out of the 3 and got a 1. 3 out of here and got a 3. Took a 5 out of here and a 5 out of there. Then I can also take this 5 out of here and this 3 out of here and get my final answer of 9 over 2. Perfectly acceptable. Okay. I guess I could multiply all those together, get a big huge number first, and then divide. But it seems kind of excessive. Okay, how about, okay, this is, I need to do this first. What is this? This is this here. 3 into 18, 6 times. So this would be negative 12 over 1 divided by. So that's keep, change, flip. And let's see, they both 2, 6, what goes into, well, let's just take the 2 out. You get a 6, 2 out, you get a 20. You can take another 2 and get a 3 and a 10. So this would be 27, don't lose the negative, over 10. Yeah, okay. And then let's try that with rational expressions, okay? Same way. Let's look at the numerical coefficients first. The 4 over 7, 3, and 8. Take the 4 out. So the number part's going to be 1 times 3 is 3, and 2 times 7 is 14. So that's that part. And then I've got x squared on top, and x, see that x underneath? So that's going to leave me 1x on top. And then I've got y on top and y3 underneath. So that's a 1, which means there's left over 2 underneath. If you want to write this out, this is x squared minus 1 equals x. This one is y, 1, minus 3 equals y, negative 2, which is the same as 1 over y2. And that's why that's on the bottom. Okay? Both ways work just fine. All right, there's a lot going on in this one. Let's work with the numerical coefficients first. Let me make my line skinnier. Okay, I can take a 5 out of this and get 5, and take a 5 out of this and get an 11. I can take a 3 out of this and a 3 out of that. That's going to give me a 40. Can I take anything else out? I don't think so. 40 on top and 33 on the bottom. They're big numbers. They're not prime numbers, but they don't have any factors in common, so you can't go any farther. So leave that there. Let's see, x's. I've got 2 x's on top, 7 x's underneath. That's going to leave me 5 x's, and they need to go on the bottom. The y's are, let's see, I've got 4 y's on top. Y's going to be 4, and they're also on the bottom. That's my answer. Okay. How about this one over here? Let's see, keep, change, flip. So keep. I could reduce this one though, as it sits here. Change. Okay, keep, change, flip. And this is A. I got 4 A's on top. Minus 1 is 3 A's on top. And B squared on top. And this one is 4 and B to the 4th. So I can take 2 out of here, and I'm left with 2. So this would be what? A to the 3 times 4 over B squared. So this looks a little funny. There's nothing wrong with that. If you'd like to write it 4A3 over B squared, that might look a little better to you. But that's fine. They're all multiplied together, so that looks fine. And this last one, keep, change, flip. So some of these you could just reduce, like over here I could have reduced the A's on the spot. So let's reduce the W's here. We have 8 and 9, and then we have 12 W's up top, 3 underneath, which means leftover W's are on top. 12 minus 3 is 9. We'll put them back up on top here. Okay. There are a lot of ways to do this problem. I'm gonna start here. Okay. And then there's a z to the 6. You can always reduce your polynomials, your monomials, your rational expression as it is. So keep, change your division to a multiplication, and flip your other one here. Let me go ahead and reduce the z's. W's, 5 W's here. Okay, the z's, there was 8 on top, 6 underneath. That's going to leave 2 here. Z 8 minus 6 is Z2. Okay. All right. How am I doing? Did I flip? I did. Oh, you know what? I didn't. Oh. All right. So I flipped the number part, but then I didn't flip the Okay. That's called doing too many steps at one time. So let's just flip this thing. And because apparently I can't flip it and take care of the z's at the same time. So let me flip it first. And then How many z's do we have altogether? We have 6, and 6 is 12, minus the 8. You see that? We have z to the 6 plus 6 minus 8. I think that's 4, right? Yep, positive 4. And altogether, we've got w's, we got 9 on top, and we got 5 underneath, so that's 4. So these are on top. And then I don't think anything reduces. So on top we have 2 times 8 is 16. And on the bottom we have 9 times 13. Put that in the calculator. I'm hoping that's 117 if I did that right. And then the z's were both, and the w's were positive. So that means they've got to go on top. So that should be the answer to that one. Okay? Make another video for the other one.